This is an introductory lesson to angle relationships. An angle is a figure formed by two rays with a common endpoint called the vertex. In the diagram, point P is our vertex. There are different ways that we classify angles. We often classify angles based on their degree measure. An acute angle is an angle that measures greater than 0 degrees and less than 90 degrees. Angle DEF is an example of an acute angle because it measures 53 degrees. An obtuse angle is an angle that measures greater than 90 degrees and less than 180 degrees. Angle GHI is an example of an obtuse angle. Its measure is 121 degrees. A right angle is an angle that measures exactly 90 degrees. In angle KLM, see that special symbol like a box in the corner? This symbol tells us that this angle truly measures 90 degrees. A straight angle is an angle that measures 180 degrees. A straight angle is essentially the mathematical way to say a straight line. Angle ABC measures 180 degrees because it is a straight line. Congruent angles are two angles that have the same measure. Notice in our diagram here that angle TAG measures 48 degrees and that angle CBS also measures 48 degrees. These two angles are congruent angles. The notation that we use to show that these two angles are congruent is as follows. We write out angle TAG and we put the congruent symbol in between the following angle, which is angle CBS. Do not forget that this symbol means congruent. Vertical angles are a pair of opposite congruent angles formed by intersecting lines. These angles are called vertical angles because they share the same vertex. In this case, we have two intersecting lines. From that, we have two different pairs of vertical angles. Angle 1 is vertical to angle 3. Angle 2 is vertical to angle 4. Since we have two pairs of vertical angles, these angles are also congruent angles. We can write this out using the congruent symbol in between each angle pair. So in our first statement here, angle 1 is congruent to angle 3. In our second statement, angle 2 is congruent to angle 4. Complementary angles are two angles whose measures sum to 90 degrees. Notice that in example 1, we have two angles. One angle measures 40 degrees, and the other angle measures 50 degrees. When we add these two angles together, they do sum to 90 degrees. One way we know that they sum to 90 degrees is we see that symbol again. Remember that that symbol means that these two angles create a right angle. Notice in example 2 that we are given two angles, but they're not together. Just because the angles are not together does not mean that they are not complementary angles. If we were to take the sum of 27 degrees and 63 degrees, we find that these two angles do sum to 90 degrees, proving that they are also complementary angles. We also have another angle relationship that we call supplementary angles. These are two angles that sum to 180 degrees. In example 1 here, if we were to take 60 degrees and add it to 120 degrees, we would find that the sum is 180 degrees, proving that these two angles share a supplementary relationship. Within the relationship of supplementary angles, we have another relationship called a linear pair. These two angles still sum to 180 degrees, but they are also adjacent angles, which means that they are next to each other and share a common vertex. In the diagram, we see that S is our vertex that the two angles share. If we were to create an example, we could say that angle RST measures 110 degrees, and that angle TSU measures 70 degrees. These two angles are a linear pair because they are adjacent and they sum to 180 degrees. We know that 110 degrees added with 70 degrees gives us a sum of 180 degrees.